Okay, so now we're going to learn one of the rules that's going to make your life a lot easier. It's called the power rule. So before, when you were taking derivatives using the limit definition of a derivative, you had to go through a long process to figure out what the derivative of any function was. Through that, you learned a couple of things that you may or may not have memorized at this point, but we know that dx of x to the first power is just 1. And then we should also know that dx of x squared is 2x, and dx of x cubed is just 3x squared. If you notice, there's sort of a pattern to all this, and we can come up with the conclusion that dx of x to some n power equals nx to the n minus 1 power. And that's always going to be true. And that'll help you take your derivatives a lot quicker. So examples you can use to just make sure you have this down. If you try to take dx of x to the 110th power, that's just going to be equal to 110x to the 109. Pretty simple. If you wanted to take dx of 1 over x squared, we know that if you have a power in the denominator, that's just the same thing as saying a negative power. So that's going to be the same thing as dx of x to the negative 2. And then when we try to take this derivative by the power rule, you just get negative 2x to the negative 3, or negative 2 over x cubed. And you can confirm all this if you want to using the limit definition. And then one more, if you try to take ddx of square root of x, we know that roots are just fractional powers, so this is x to the 1/2. So that's going to be dx of x to the 1/2. And then using the power rule, you bring this 1/2 down, and you're left with 1/2 x, and then you take away 1 from the power, so that's the negative 1/2, which can be rewritten as 1 over 2 square root of x. So now we're going to take the power rule that we just learned and apply it to physics. You know a general sort of expression for a position function is given by x of t equals 1/2 at squared plus bt plus c, where a gives your acceleration, that's a constant, some constant value, and b and c are also constants. And this function describes the position of your object. And we know that velocity is the derivative of position. It's the rate of change of position over time. So if we just use the power rule to take the derivative of this to find our velocity, we can get that v of t equals dt of x of t. And that's just going to be, using the power rule here, we bring down our 2 times 1/2 times a times t. The 2 and the 1/2 cancel out, so you're left with at, and the derivative of bt would be the constant, it's just going to be b, so plus b, and then c is a constant, and the derivative of the constant is 0. So this is your velocity function. This describes, how fast your object is moving at a given time. And we also know that acceleration is the derivative of velocity. So if we want to find our acceleration, we know that a of t is going to be dt of b of t, which is the derivative of this expression here, at plus b. So we know that the derivative of a constant is 0, so that's just going to drop off. And the derivative of at is just going to be a. So this matches what we said before, where this was the expression for your position, where a gives your acceleration. Using the power rule to actually find the expression for the acceleration, we see that that's true. So it matches what you've learned in two different ways. So now we're going to look at another rule of taking derivatives that's going to make your life much easier. This one's called the product rule. So what if we had something crazy, like we want to take the derivative of x to the fifth plus x to the fourth plus 2x cubed plus x squared plus 4x plus 90, all of that times x cubed plus x plus 1. We could actually multiply all this out and gather all your terms and take the derivative using the power rule, but that's going to take you a lot of time and it's going to be really painful. So there's a rule that you can use to take derivatives like this. So at first you might kind of think that, well, it's going to be the derivative of this times the derivative of this, which isn't actually true. But the correct form of the product rule is actually if you want to take the derivative of some function f of x times g of x, so you have a product of two functions, that's going to be the derivative of f of x times g of x plus f of x times the derivative of g of x. Or another way you can write this is f prime of x g of x plus f of x g prime of x. So that's your product rule for taking derivatives. So now if we go back to this example, well, we can now use the product rule to take this derivative. So if we do the derivative of the first, so the derivative of, we'll call this our f of x, times our g of x, so this derivative is just going to be 5x to the fourth plus 4x cubed plus 6x squared plus 2x plus 4. And that's going to be times our function g of x, so that's just x cubed plus x plus 1. So that's our first part, plus the derivative of our function g of x, so that's going to be 3x squared plus 1 times this whole thing, so x to the fifth plus x to the fourth plus 2x cubed plus x squared plus 4x plus 90. Then if you wanted to, you could actually multiply all that out and get your derivative. Okay, so we're going to do one more example of using the product rule. If you want to take this derivative, dx of x plus 1 over x squared. At first, it might look like you can't use the product rule to take this derivative, but we can rewrite this expression as a product. And that's just the product of our derivative x plus 1 times 1 over x squared. As we know, this 1 over x squared is actually just x to the negative 2. So that's going to be ddx of x plus 1 times x to the negative 2. So now we can take this and use our product rule. So we're going to do the derivative of the first, which is x plus 1. So the derivative of that we know is just going to be 1, times the second function, which is x squared, so 1 times x squared, or x to the negative 2, sorry, plus the derivative of our second function, which is x to the negative 2. By the power rule, the derivative of that is going to be negative 2x to the negative 3, that should be a 3. times this function, so times x plus 1. Okay, so once you have this, you can kind of simplify everything down. This just comes down to 1 over x squared, because you can rewrite that as a fraction. And then plus this, you have your x plus 1 in the numerator, and then this negative 2 is also in the numerator, because those are all the positive powers. So plus negative 2 times x plus 1 over, and then now you have x to the negative 3, which is x cubed in your denominator. And then if you wanted to multiply this through, you would be left with still your 1 over x squared plus negative 2x minus 2 over x cubed.